This is IBM research, and we're supposed to be pushing the limits of science. I mean, that's our job, to look for exploratory challenges that help us drive science.
There's two types of innovation. There's incremental innovation, improving existing products and advancing them in sort of a linear fashion. But we like to present our teams, and our teams even generate for themselves, grand challenges.
So what makes a grand challenge is, first of all, it has to be difficult, right? It has to be a challenge. It has to be inspiring.
Chess was a grand challenge that was identified in the 60s. People said that no computer will ever beat a human chess grandmaster.
It would be a landmark to show that we understood computer technology well enough to take on this task that we thought was really restricted to human intelligence. And we did it with Deep Blue.
Another grand challenge is around using computers to map the human genome. We call the computer Blue Gene, Blue for IBM, Gene for genomics. We encourage people to work across disciplines on these grand challenges. And it's these sorts of things that produce the big breakthroughs that IBM has done for the past 100 years.
Language is an area where, from the very beginning of the computer era, people kept expecting computers to do reasonably well at. They expected computers could talk. They could understand what it is you're asking for, and then they can do that thing, or they can answer that thing. And so far, the computers have failed to deliver on this promise.
There's something called open question answering that has been a problem in computer science from the beginning. It's much more difficult than search. It's not about a single keyword. It's much more the way normal humans communicate.
Humans communicate very fluently in images, in literature, in writing. People get natural language because it's a human artifact. They relate those words and those phrases and those ideas back to the way they think. They ground that information in human cognition, their human experience. But that's not written in a formal database language or a formal mathematical language that computers can understand.
Computers are used to unambiguous things. Human language, completely the opposite. Last night, I shot an elephant in my pajamas. How it got in my pajamas, I'll never know. We know what the pajamas are modifying, but the computer, it's just as likely that the elephant's wearing pajamas.
And that's where computers struggle dramatically, and that's where we want to make them better. IBM executives were really interested in doing sort of the next big grand challenge, the next Deep Blue.
Do you have any questions before we begin? Everything's going to work pretty much exactly the same way it did for you on the show. The only difference is we do not have a time limit, so we will play.
I had heard some rumblings about maybe we would take a look at doing question answering on a big scale. And maybe we would look at doing something that could take on a real challenge, like Jeopardy!
Deep search and deep analytics was becoming a tougher and tougher problem for general purpose computers. So we said, well, let's build a specialized computer to do this and do it at an incredibly fast rate.
Let's take a look at our categories. Philosophic ideas, Bergopolis.
Ultimately, we're not playing Jeopardy! What we're trying to do is make computers better at processing all that natural language content. Can you imagine computers communicating more fluently in natural language?
In 1778, this man, the Elder, suffered a fatal collapse minutes after speaking against colonial independence. Watson.
Who is William Pitt?
That is correct. Watson wins the game.
It is irresistible to pursue this, because as we pursue understanding natural language, we pursue the heart of what we think of when we think of human intelligence.